Solar brothers and sisters, good morning to all. Today's topic is quantum number and important features of quantum mechanical model of atom. It is the continuation of atomic structure. First we discuss about quantum number. What is the definition for quantum number? The number which designate and differentiate between various atomic orbital and electron in atom. This known as quantum number. The quantum number can be classified into, there are 4 types. First one, principal quantum number. Second one, azimuthal quantum number. Third one, magnetic quantum number. Fourth one, spin quantum number. There are 4 types. First, principal quantum number notation, small n. Azimuthal quantum number notation, small l. Magnetic quantum number notation, ml. Spin quantum number notation, small m and s. These are the notation. We have to discuss one by one. First, principal quantum number. These are the atom of element in the center which carrying the positive charge. This name is called nucleus. Nucleus consists of proton and a neutron. This name is called nucleon. This is nothing but orbit. Is a path by which electron revolve around the nucleus in the fixed path. This name is called orbit. Principal quantum number determine size and energy level in which electron revolve around the nucleus in the fixed path. Here, principal quantum number depends upon the size. This is an important one mark, maybe ask need and theory. Principal quantum number depends upon the size of the orbital. If size of the orbital increases, increase with the principal quantum number. This is point number 1. Point number 2. For n value is a greater, the electron will be located far away from the nucleus. The electron can be located far away from the nucleus. That is point number 2. It also identify the energy level or designate by the cell. That is KLMNO. That is a K cell, nothing but the orbit very close to the nucleus. Next, LMNO. K cell is a n is equal to 1. Is a n nothing but orbit or principal quantum number or energy level or main cell. These all are same. Here, size of the orbital depends upon the n value. If n value increases, size of the orbital also increases. This covered by the formulas. The number of subcell in main cell equal to n. The number of orbitals in main cell n square. The number of electrons in main cell should be equal to 2n square. What is the formula? Number of subcell in main cell, that is a n. Number of orbital in the main cell, that is a n square. Number of electron in the main cell, that is a 2n square. For example, n nothing but principal quantum number, cell maximum number of electron. Here n value 1, 2, 3, 4 and so on. Cell n value 1 mean what cell? K cell, L, M, N and so on. Maximum number of electron. If n value 1 is a 1 square 2. Maximum number of electron is a K cell 2. Likewise L cell 8, M cell 18, N cell is 32. If n value given, what cell possible? L cell. In L cell, maximum number of electron is 8. Simple. Easy to do. This type of question may be asked in the 1 mark. Another one. Second one. Azimuthal quantum number. Azimuthal quantum number, another name called orbital angular quantum number. Quantum number or moment. It is a momentum. Or subsidiary or secondary quantum number. All are same. Azimuthal quantum number determine orbital angular momentum and shape in which the electron located in the subcell. This covered by the formula. Here, azimuthal quantum number notation small l. That is a L value depends upon the n. That is a L should be equal to 0 to n minus 1. Because of azimuthal quantum number value depends upon the principal quantum number. Clear? This covered by a formula the number of orbital in subcell should be equal to 2n plus 1. The number of electron in subcell should be equal to 2 into 2l plus 1. This type of question may be asked in 1 mark. Clear? It is a azimuthal quantum number. It is also determine orbital angular momentum and three-dimensional shape of the orbital in which electron located in the subcell. For example, L nothing but azimuthal quantum number subcell orbitals maximum number of electrons. Here L value, lowest value 0, 1, 2, 3 and so on. L value 0 means what subcell possible? That is a S subcell. What is the formula? The number of orbital in the subcell 2l plus 1. The number of electron in the subcell 2 into 2l plus 1. Here what cell possible? S subcell. Here number of orbital in the S subcell, how many orbital present? Only one orbital. So what is the formula? 2l plus 1. L value 0, how many orbital? Only one orbital. This is only one orbital. How many electron possible? There are 2 electron possible. What is the formula for find out the electron? The number of electron present in the subcell 2 into 2l plus 1. Suppose L is equal to 0, whole 0, remaining is what? Only 2 electron possible. Another subcell, P subcell. In the P subcell, how many orbital possible? That is a 3 orbital possible. How many electron? 6 electron. Each orbital contains the 2 electron. Totally how many electron? 6 electron. Another one is a D subcell. In the D subcell which containing the 5 orbital, how many electron? 10 electron. Another one is a F subcell. How many orbital? 7 orbital. How many electron? 14 electron. Answer. Clear? A subcell, how many orbital? Is a only one orbital. Is how many electron? 2 electron. L value 1, that is a 3 possible value, that is a -1, 0, plus 1. This explained by the magnetic quantum number. Is a what subcell? P subcell. P subcell totally how many orbital? 3 orbital. How many electron? 6 electron. The T subcell totally how many orbital? 5 orbital. How many electron? 10 electron. F subcell how many orbital? 7 orbital. How many electron? Is a 14 electron. This subcell can be explained by the spectroscopic terms. Here S for sharp, P for principal, T for diffuse, F for fundamental, etc. That is a subcell can be explained by the spectroscopic terms. S means sharp, P means a principal, D means a diffuse, F means a fundamental. Next, the relationship between orbital angular momentum and azimuthal quantum number. That is orbital angular momentum rotation capital L should be equal to h by 2 pi square root of L into L plus 1. Here h bar nothing but h by 2 pi. This equation becomes, that is L h bar square root of L into L plus 1. Here capital L nothing but orbital angular momentum. Is a small l nothing but azimuthal quantum number. Next, subcell notation. It is a n value, L value, subcell. It is a notation. Here, lowest n value 1, only one, n is equal to 1 means L value only one value. This a what orbital? L is equal to 0 means what orbital? S orbital. That is a notation 1s. Another one, n value 2, L value 2 value possible, 0, 1. This name is called 2s, 2p. N value is a 3. There are 3 value possible, 0, 1, 2. Here 3s, 3p, another one 3d. These are the notation. N value 1 means L value 0, 1s orbital possible. N value 2 mean 2 value for L, 0, 1, 2s, 2p. N value 3, 3 values possible for L, 0, 1, 2. 0 means 3s, 1 means 3p, so 2 means 3d. L value 0, s orbital, L value 1, p orbital, L value 2 is a d orbital. In the s subcell, how many orbital present? Only one orbital. How many electron possible? Is a 2 electron possible. Is a b subcell, how many orbital possible? 3 orbital possible. How many electron? Is a 6 electron. The d subcell, how many orbital possible? Is a 5 orbital possible. Total how many electron? 10 electron. This explained by the azimuthal quantum number. Another one, magnetic quantum number. Magnetic quantum number denoted by small l, m, l. This is a magnetic quantum number determine spatial orientation of orbitals. M value depends upon the azimuthal quantum number. That is, M should be equal to plus L through 0 and minus L. That is, value of M depends upon the azimuthal quantum number. For example, here n value, n is equal to 1, suppose 1. What about L value? L value is 0. What subcell possible? There is a n value 1 means L value 0. What subcell possible? S subcell possible. What are the orbital possible? Orbital. only one orbital. Maximum number of electrons. Here, S subcell, how many orbital possible? Only one orbital. In this orbital, which containing the two electron. One is clockwise direction, another one is anti-clock direction. Totally how many electron? Two electrons. Another one. Here, n value is a 2. 2 means is a totally how many values possible? Is a 5 values possible. Sorry. Here n value, okay. 1. N value 2 means what are the L value? 0, 1. 0, 1 means here what about is a M cell? That is a M cell notation. What are the cell notation possible? That is a M value is a -1, 0 is a +1. Is a M value. What are the orbitals possible? Totally is what? 3 orbital. Here 1, 2, 3. Each orbital containing the 2 electrons. This name is called Px. This name is called Py. This name is called Pz. Totally how many electron possible? Is a 6 electron possible. N value 1 means L value 0. So only is what here M value. What about M value? M value nothing but 0. L value 0 means M value also 0. This means representation of S subcell. What are the orbital? Only one orbital. Maximum number of electron 2. If n value 2 means L value is there are 2 possibility 0, 1. What about M value? -1, 0, +1. Totally how many possible orbital? 3 possibility orbital. Totally how many electron? 6 electron. Another one. See n is equal to 3. Is L is equal to 2. L is equal to 2 means what about M value? Is a -2, -1, 0, +1 is a +2. Totally how many value? 5 values. This name is called Txy, Tyz, Tzx, dx square minus y square, Tz square. Each orbital containing the 2 electrons. Totally how many electron possible? Is a 10 electron possible. Clear? L value 1 means what about M value? M value 0. This means S subcell which containing only one orbital, 2 electron. Another one, L value 1 means what about M value? -1, 0, +1. This means S subcell, that is a P subcell which containing the 3 orbital. These are the P subcell which contain how many orbital? 3 orbital. How many electron? 6 electron. If N value 3, L value 2. L value 2 means totally how many values are possible? 5 value. This is a 5 value representation of D orbital. D subcell which containing how many orbital? 5 orbital. Each orbital containing the 2 electron. Totally how many electron? 10 electron. Clear? This type of question may be asked in the 1 mark. Principal quantum number determine size and energy level. Azimuthal quantum number determine angular momentum and 3-dimensional shape of the orbital. Magnetic quantum number determine spatial orientation of orbital. Another one, spin quantum number. Spin quantum number denoted by the small m and suffix s. It determine the direction of spin of electron or determine spin of electron. Spin quantum number which have the only 2 values. First one, plus of or spin up and minus of or spin down. This name is called rotated by the direction clockwise. This direction anti-clockwise. When clockwise and anti-clockwise spin of electron produce the magnetic field. Magnetic field covered by the formula plus or minus half into small n, where n nothing but a number of unpaired electrons. Clear what is the formula total spin? Plus or minus half into n, n nothing but a number of unpaired electrons. This covered by the is a spin quantum number. Next, what is the formula for spin angular momentum and spin quantum number? That is a relation between spin angular momentum and spin quantum number. That is mu s should be equal to h by 2 by square root of s into s plus 1. Here mu s nothing but spin angular momentum, s nothing but spin quantum number. This can be explained by the quantum number, the number which designate and differentiate between the various atomic orbital and electron in atom. This name is called quantum number. Quantum number can be explained by there are 4 types: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Next, we are discuss about important features of quantum mechanical model of atoms. Quantum mechanical model of an atom is the picture of structure of atom, which result from the applications of Schrödinger wave equation to the atom. That is this equation nothing but motion of electron in atom moving by the 3-dimensional space. This covered by the formula del squared psi plus 8 pi squared m divided by h squared into e minus v into psi should be equal to 0, where del nothing but Laplacian operator, psi nothing but amplitude of the wave, that is a wave function. M nothing but mass of electron. H nothing but Planck's constant. E nothing but total energy of electron. V nothing but potential energy of electron. This is known as Schrodinger wave equation. What is the formula? Del squared psi plus 8 pi squared m divided by h squared into E minus V into psi should be equal to 0. This explains the important features of quantum mechanical model of atom. This is point number 1. Energy of electron in atom quantized, that is electron which have only certain specific value. This is point number 1. Energy of electron in atom quantized. Next, point number 2. Extents of quantized electronic energy state, which is the directly proposed to the wave property of electron. This means the solution of Schrodinger wave equation gives energy level. This is point number 2. Point number 3. According to the uncertainty principle, this principle explained by the Heisenberg. What is the definition? It is impossible to measure simultaneously both position and velocity or momentum of microscopic particles with absolute or accuracy. This covered by the formula, that is delta x into delta p greater than or equal to h by 4 pi, where delta x nothing but uncertainty position of the particle. Delta p nothing but uncertainty momentum of the particles. Here sign greater than or equal to the product of delta x and delta p always greater than or equal to h by 4 pi. We consider probability of finding electron at a different position in the atom. This explained by the point number 3. Point number 3 nothing but uncertainty is a principle explained by the Heisenberg. Important features of quantum mechanical model of atom, that is a 4th point. As a consequence of quantum mechanical introduced the concept of orbital. Orbital is a 3-dimensional space around the nucleus. Here, probability of finding electron is a maximum. This is known as a consequence of quantum mechanical introduced the concept of orbital. Another point number 5. That is a wave function What is the notation? That is a psi. For electron, introduce atomic orbitals, that is orbital atoms. Another one, point number 6. Point number 6, nothing but the probability of finding electron at point within the atom is directly proposed to the square of orbital angular momentum quantum number, that is psi square. Psi squared is also known as density probability. So density probability always is a positive values. Psi is the wave function which consists of positive and negative value. These are the known as important features of quantum mechanical model of atoms. Let us recap the quantum number. First one is a principal quantum number. Here, maximum number of subcell in main cell should be equal to n. Maximum number of orbital in the main cell should be equal to n squared. And maximum number of electron in the main cell should be equal to 2n squared. Another one formula. The maximum number of orbital in the subcell should be equal to 2l plus 1. And the maximum number of electron in the subcell should be equal to 2 into 2l plus 1. And m value depends upon the n. That is m should be equal to minus l through 0 and plus l. Then spin quantum number. Total spin should be equal to plus or minus half into n. Here n nothing but number of unpaired electron. Next, important features of quantum mechanical model of atom can be explained by the Schrödinger equation, that is del square psi plus 8 pi square m divided by h squared into E minus V, psi should be equal to 0. You have to practice all the concept and the terms, equation, fundamental formula and get highest mark. Good luck.